Hello, welcome back to Building Integrity. I'm your host, Josh Porter, and this hurricane season taught me one very important thing. Wind speed, and which is also how we categorize hurricanes by category, is one of the least important aspects about a hurricane. This is contrary to everything I've been taught. It's basically contrary to the way the codes are constructed here in Florida, and I think it goes against honestly the way the general public views hurricanes. When we watch meteorologists on TV talk about hurricanes, they always talk about, oh, it's a category 1 or it's a category 2 or it's a category 3, as if that's the most important thing about it, how fast the wind is going around the eye of the storm. But it's really not. And hurricanes actually have several qualities, 6 I'm going to talk about in this video very briefly here, and many of these qualities are much more important than the wind speed. So the first category is wind speed, which we talked about. The second category is how much rainfall a hurricane is going to bring. The third category is how big is the hurricane. Okay, that really matters when we're talking about how much damage a hurricane can do and what kind of devastation it can do to an area. How big is the thing overall? The other thing is its track speed. In other words, how quickly is that hurricane moving across the planet? If you look at Hurricane Charlie back in 2004, it had a small size and it moved quickly. So the damage was very minimized compared to Hurricane Ian, which had a very large size and moved very slowly. The fifth item, and it's going to be one of the primary topics of this video, is storm surge. Storm surge being probably one of the most important categories in a hurricane. And the sixth quality of hurricanes that sort of goes along with storm surge is erosion, particularly along the shorelines, right? So we're going to be talking a little bit about storm surge. We're going to be talking about erosion. One of the things that I want to remind people in this hurricane that happened here in Southwest Florida, we've had it hit by another hurricane on the East Coast, Hurricane Nicole, which also brought a little bit of storm surge, but a lot of erosion, and that erosion caused a lot of structural damage, which we'll cover maybe in a future video. The interesting thing with Hurricane Ian, though, is that it possessed almost all of these qualities in spades. It had fast-moving wind, it had record rainfall, it had a massive size, it had a very slow track speed, and it brought a lot of storm surge damage and erosion damage along with it. Okay, let's talk about the rainfall that Hurricane Ian brought. Before the hurricane made landfall in Florida, Central Florida and parts of southern and southwest Florida were already experiencing record rainfalls. I mean, this is like just day after day, week after week. The river was at an all-time high, Peace River, which runs from near my hometown down into Charlotte Harbor. This river was already at peak cresting levels for most people's lifetimes that live down here, and this is all again before the hurricane hit. And so when the hurricane came and it brought just intense and massive amounts of rain, the river could just completely went overboard and just flooded parts of central and southwest Florida that had never ever been flooded, as far as I know, in recorded history in America here. And so you have houses that just weren't designed, they're just not high enough. You can't build high enough when you're building in an area that's not in a flood zone and it has no history of ever being flooded. And this did incredible amounts of damage. There were people like my brother who was actually, his entire family was landlocked way up away from the coast. They don't live anywhere near the coast. They live about an hour from the coast, and they were actually landlocked because his lot was just high enough to not get completely flooded, but all of the streets and surrounding area around him was completely underwater. They say that in some parts of Florida that we had what would be called a 1 in 500 year storm rain event. And there was one county, they actually calculated it out as a 1 in 1,000 year rain event. Now what this means is when you hear about storms that are a 1 in 25 year event or a 1 in 100 year event or a 1 in 1,000 year event, what we're talking about is probability and statistics. What is the probability that that storm can happen with this much rainfall? And statistically, it's the same statistical value as this storm occurring once in 1,000 years, for example. But it doesn't necessarily mean that it's only going to occur once in 1,000 years. It just means that probability and statistics and based on history and meteorology and all this other stuff, that's the likelihood of it occurring. So this was really, Hurricane Ian was really a one for the record books, let's just say. Now the storm surge, let's talk a little bit about storm surge, because that's going to be the main focus of this video. One of my problems or complaints in Southwest Florida particularly, but in Florida in general and or other parts of the state, is that every single hurricane, the TV meteorologist, now I'm distinguishing TV meteorologists from actual real meteorologists, okay? The TV meteorologist will get onto the airwaves and they will sit there and tell you there's going to be 20 feet of storm surge, there's going to be 10 feet of storm surge, there's going to be 15 feet of storm surge. And my entire life, I've lived in Southwest Florida my entire life, and I'm telling you, no hurricane ever brings in storm surge until Hurricane Ian. And what this creates is a problem where you're hearing these meteorologists, they're trying to use all these scare tactics and talk about storm surge. They don't really have a good grasp as far as being able to read the equipment, the radars, the meters, the barometers. They don't really have, I don't think, a good grasp on whether a storm will actually bring in storm surge or not. We know what causes storm surge. I'm not going to get into that into this video. Meteorologists generally understand that, and sort of a lot of scientists and engineers. But in the moment, the hurricane's a day offshore, I don't think these folks have a really good idea, because year after year, every single storm, they tell you this storm's going to bring 15, 20 feet of storm surge. And every time there's not 1 inch of storm surge that comes in, or maybe a few inches, but it's like not noticeable, right? Nobody reports on it. Then all of a sudden Hurricane Ian comes in, and you have this exact scenario of the boy who cried wolf, right? The boy says, oh, there's a wolf coming to eat the sheep, and all the townspeople show up and they all say, okay, where's the wolf? And he says, ha ha ha, I tricked you all. Well, this happens enough and enough and enough, and then finally when the wolf shows up, the big bad wolf known as Hurricane Ian shows up, and the meteorologist cries wolf, nobody listens. And this has real consequences, because people, I can tell you story after story after story of people who stayed in their homes because they've been here for 50, 60, 70 years and have never seen a foot of storm surge. And they lost their lives because they had been conditioned to basically ignore the meteorologists when they sit there and warn you about storm surge. So I have a beef to pick, because I don't think meteorologists or TV meteorologists are being held accountable for this. It is a boy who cried wolf scenario. They don't have a good idea on when storm surge will actually show up and when it won't, and where it will show up and where it won't. And this has cost actual people's lives because 50 plus years of just basically lying to the public has caused the public to distrust what you're saying and tune you out. All right, that's my little side rant for TV meteorologists. Personally, I think they're relatively useless, but you can have your own opinion on that. I'm fine with that. Storm surge. Some of the things we learned about storm surge. And I already alluded to earlier in this video that it's really a much more important quality than wind. And the reason why is because most modern construction and most codes already account for dealing with wind. We already have windows that are so strong and so impact rated that they shoot 2x4s at them and can't break through. Fire departments have had to be retrained to figure out how to break through windows because they can't even use a saw to cut through the glass. They had to be retaught to cut around the frame to knock the window out because the windows are like practically indestructible. The houses down here suffer virtually no damage from wind on the whole. We do have a weakness, I feel, in the code dealing with roofing materials. We tend to still lose a lot of roofing materials during hurricanes. I think there needs to be some improvement in technology on how we deal with roofing materials. But for the most part, wind doesn't really cause the big damage numbers anymore down here compared to storm surge. Storm surge is the thing that has killed people. It's the thing that killed a lot of people in Katrina, was the rising waters and the storm surge issues that they had. This is the big killer, is storm surge. And one of the things I've learned in this hurricane is that, and these are things that aren't covered in the code, and these are things that people don't typically talk about. And it's that storm surge has certain qualities that need to be looked at. You can't just say, the water's rising. And that's sort of really how the code really addresses this. We have to put the only thing that's really in the code for storm surge is that if you're going to build walls below the floodplain, you have to build walls that can break away. In other words, so when the flood waters come in, the walls just give way and then it doesn't affect the superstructure, which is fine. That's good. And then the other thing that we do is we have these things called hydrostatic vents, and they're to equalize the pressure as the water level rises. But what I've never heard an engineer talk about is the actual lateral loads that the storm surge can put onto a building as the tide is coming in, as the storm surge is coming in. And not only lateral loads, but they actually have lifting forces, which I'm going to show you in great detail in this video and some interesting photos that I have for you. Now, for disclosure purposes, I can't give the name of the actual property that this is located at or its address or anything like that, and that's not really important. What's important is sort of its localized geography and where it's located on the coast. Okay, this building is in Fort Myers Beach. And in Fort Myers Beach, we have, obviously you can see in this image, we have the coastline along here, right? And so what we have is a building that exhibits certain damages in certain locations, and I find this really interesting. Now, it's hard to tell where the storm is when you go back through historical aerial images and stuff like that, in which direction the storm surge was coming in. I believe, based on the evidence and based on what we're going to look at together today, that the storm surge generally came in this direction, okay? Or maybe slightly in this direction, but I do not believe it came in from this direction. I don't think that happened. And I'll show you why when we look at some of these units. Now, these are the two units we're going to be looking at in this building. We're only looking at the first floor. These are residential units that are constructed 50, 60 years ago, right? I'm not going to get into exactly the codes that were in place at that time, but this building was constructed a long time ago, so the first floor residential floors are actually below floodplain. And the two units we're going to be looking at are units 2 and 5 on the ground floor, and the building is numbered from 1, 2, 3, 4, 5, 6, 7, and so on, okay, around the building. So the first one we're going to look at, zooming in, is Unit 2. And what I want to look at here is, this is a picture of the lanai looking this direction. Okay, you can actually see a little bit of the other lanai. So up here in the key, up at the top right, you'll see that I'm pointing at the direction that picture was taken. So we're looking in this direction at the unit before I flew in. Now, these units, I already knew these units just based on walking around the exterior of the building had suffered structural damage. I wasn't going to risk my life or have any of my staff risk their lives walking into the building and walking on any slabs that might potentially collapse. So what we did was I sent my drone in, and all these photos that you're going to see in this video are going to be taken with the drone. So this is the exterior. One of the things I want to show you is you can see down at the bottom, the foundation is slightly exposed here at this particular location. You can see where the paint line is on this pile cap. That's generally where the soil was. So in this particular photo, in this location, they've only lost a couple feet of soil. You can see that the soffit here and fascia right under the slab edge it's gone. It's been taken away by the storm surge. Now this building, to give you a little history, about 11 years ago, I was the engineer of record in my company. We oversaw the restoration of this building, and one of the things we did was we actually replaced the lanai balconies and on the first floor and the first floor walkways. So these are new modern construction, modern engineering, and this is why the actual slab itself didn't collapse, and it's actually in good shape. All of the slabs that we had done 11 years ago are in pretty much perfect condition. But the other interesting thing I want to show you in this photo is you can see that the entire hurricane shutter has been ripped off here over this window. The window's completely gone from the storm surge. You can also see in the middle that the sliding glass doors are gone, okay, from both of these units. The guardrails that would have been installed, or that were installed along the edge, are completely gone, right? They were like these picketed guardrails. They're gone. You can actually see the damage in the slab edge where they chunked out the concrete from the storm surge, the lateral force of that storm surge coming in, hitting that guardrail, bending it, and just breaking the concrete apart at the very edge. And then the other thing that we were able to observe out there was generally the height of the water. Now, in some parts of the building, we could actually see debris and water line on the building. In this particular photo, you don't see that, but what you do see is that the soffit and fascia above that lanai that we're interested in is actually pushed in, and it's crushed in, and you can see that in this image, which gives you two pieces of information. One, that the water level was about here during the height of the storm surge, and that water had a lateral force to it. It was coming onshore with a lateral force, and it pushed in those soffits and completely crushed them inward. All right, as we fly into the unit, Okay, so we're in the unit now and we are looking generally in this direction. You can see up here in the key, I drew the little red arrow. And you can see this is one of the units. Unit 2, again, was one of the ones where the slab had completely collapsed. Now this slab in this building was built of precast concrete, and it had a reinforced topping slab on it. And you can't tell from this picture, but the planks, the precast planks went this direction. So this would have been a plank, you know, this would have been a plank, and that would have been a plank. So they were oriented in that direction. And these planks aren't even, like, they didn't just fall straight down. They're actually all on top of each other. They're oriented in different angles. So you can tell that there was some sort of massive chaotic force in this unit. One of the other things, and I'll keep pointing this out as we go through the video, is just look at how stripped the unit is. I mean, there's no ceiling. There's nothing on this wall back here. You can actually see bare masonry. There's nothing on this wood wall. All the drywall, all the insulation's gone. Even more fascinating to me is where's all the furniture? This is really a really weird phenomenon that we found in a lot of these buildings on the first floor down in Fort Myers Beach, is that they were stripped clean. Now you got to remember, when I'm flying my drone in this building and taking this picture, nobody's been in this building. No contractors have come in and cleared debris. Nothing has happened. This is days after the hurricane, and nobody's been allowed to go into these buildings except for the structural engineer. So it's really fascinating to just think how many couches, beds. I mean, where was the sliding glass door? Where's the guardrail? It's all just like gone. I mean, the storm surge, I'm guessing, washed it back out, but in some cases we see that things were actually pushed through the front door. This used to be an AC unit area here. And you can see that AC was just pushed straight through the wall along with the front window on the unit. So just really fascinating, the amount of lateral force and then the amount of force that's involved in as the storm surge recedes. I think a lot of this stuff was probably pulled out of the sliding glass door and pulled back out into the Gulf of Mexico. I think the Gulf of Mexico is just full of garbage right now, would be my guess, at least partly around the coast where it's shallow. Okay. If we turn the camera a little bit, so we turned a little bit to the right, we're now looking generally in this direction. You can see that we have piles here. It's hard to see. You can see piles here. We've got a pile cap here, and then we have a column located here. It's a little hard to tell because there's still some wall material on it, and then there's beams that go across. Now, this particular building is considered a slab and column. A column and beam design. So these walls that are underneath the beams, and I'll hatch those in for you. These walls here are actually just infill walls. They're non-structural walls. And then this wall here, it would be another non-structural wall. So the walls between the columns are not bearing load, which is a good thing because the way this building was built, those walls were actually partially built on top of the precast slabs. You can see that right here. It's a little tight to see, but the walls actually sit on top of the precast slabs. Now, when those precast slabs fell, they actually created sort of like a torque at the ends and broke the walls. You can see the block on the wall is broken there, and you're actually, what you're seeing in this light area here is you're actually seeing through the wall into the next unit over where the slab did not collapse, but you're seeing broken block there. Okay. So the second unit was one of the ones that collapsed. That's why it's highlighted here. The fifth unit is also another one that had collapsed. But we had actually found damage in units 3 and 4 as well, which I'll get to a little later in the video. But I just kind of wanted to bring us back to this orientation. Again, we're talking about storm surge coming in probably in this general direction. And we're going to now look at unit 5. So unit 5, looking at this, you can see up here in the key, we've got it highlighted, right? And this picture is taken standing just outside and looking in towards this side balcony. So this unit, being a corner unit on the building, has 2 balconies. It has one on this side and it has one on this side. And we'll show you angles of both. Now, for the balcony that we're looking at, you can actually see the open web steel joist from the balcony above. It's the only second floor balcony that actually collapsed on this building from the storm surge. But as I showed you in the previous pictures, the storm surge was definitely battering against that second floor slab up there. Here again, you can see that the that the fascia and soffit around this, just underneath this slab, is gone, but the slab is in good shape, and the new beams that we had added is in good shape. The storm shutter, you can see, is just completely battered and gone. The guardrail's gone, everything's gone, and then of course you can see the precast planks down here at the bottom, laying on the ground. Because again, I'm pre-telling you that Unit 5 has these collapsed slabs in them. So we're going to take a look now from the other direction. So now we're looking in this direction into the unit. Notice a couple differences right off the bat. One, we didn't lose the whole bottom fascia. You know, yes, we lost the guardrails. Yes, we lost the slider. Yes, we lost, you know, this window and some of the wall below it. But the other interesting thing to contrast on this side of the building is that the second floor soffit isn't pushed in at all. So if it saw lateral forces, they were so minimal that they didn't push in or crush that little stucco soffit area there in any way, shape, or form. And you'll see that throughout the rest of this side of the building as I show you those pictures later. But going on in, flying the drone in from this direction, and then again, now we're standing here, or we're flying here, we're looking in this direction. And what the opening you see on the right is actually this opening here to our right, okay? Just to kind of orient you guys. You can see the slab is collapsed. But again, the planks are going in all sorts of different directions. Particularly, you can look at this plank. You know, these aren't straight, not all of them. Some of them are kind of straight, but they're laying on top of each other, right? And if we go a little further in and we look into that corner, so now we're kind of looking into this corner of Unit 5. And you can see, again, sort of like what we saw in Unit 2, we saw that the slab prying and breaking the wall apart as it fell, these planks, and breaking this one apart as it fell. But what's really interesting is in the far right corner, because the wall was sandwiching and sort of clamping down the slab, because it's partially sitting on top of the edge of the precast plank, because it's sandwiching it here, and you've got this pretty heavy force from this wall, and you've got the beam resisting and pushing against it, it actually acted like a vise and clamped the slab. And you can see in this right-hand side of this image that the slab itself is the thing that actually snapped and broke and stayed put. So I just thought that was an interesting thing to look at, and it kind of shows you the forces that are involved to be able to snap and break concrete precast planks, steel tendons, and reinforced topping slabs. Now, there's two hypotheses for what caused these slabs to collapse. And what we're going to do is we're going to kind of talk about each one. So here we're looking at a cross-section of the building. We're talking about, you know, the beach is this direction. And so we're kind of looking through the building like a slice through an apple. I've mentioned that in other videos for people who don't know what cross-sections are. And we're talking about water that had at least reached up to here. And we know that because, again, those soffits on those slabs, there's those slabs that were sticking out and those soffits that were here, and those soffits were damaged in those pictures early on that we saw. So we know the water got up there, and we also know that the ceiling here was completely stripped of all of the finished materials and everything. So we know water was in, it completely filled up the unit. Now, if the slabs had collapsed, here you can see the precast planks, if you will. I kind of hatched those in green. And if you see that, if you think, okay, well, Josh, the thing that caused the slabs to collapse would have been this immense amount of weight that was on top of the slab. So you're thinking this is all full of water, and that's a lot of weight. But the problem is you have a couple issues. Like one, you have buoyancy, and you have not necessarily too much buoyancy, but you have an equalization of pressures. So whatever pressure this water would have been exerting on the slab, you would have expected that pressure to be all over the slab. So those pressures should equalize. Now you could say, well, yes, but at some point you may have had some sort of undercurrent or undertow where this water is being drawn out in this direction momentarily, which creates an excessive downward force on the slab, causing it to break. There's a couple reasons I don't agree with that, but let's just leave that where it lies and let's move on to the second theory. So the first theory is you have a ton of water on the top. The water underneath the building kind of gets drawn out at some point, you know, undercurrent or something like that, causes an excess of load on the slab, crashes it down to the ground. The other scenario is that the storm surge, as it's coming in, it's coming up the continental shelf and it's coming up the beach line, okay, with an angular upward trajectory. Okay, I'm going to actually redraw this a little bit better. So you kind of have this overall average angular force. So the water is essentially kind of coming up. You can kind of imagine it like a wave, right? And it's kind of coming up, and it comes up in layers. And we have video showing that from people's like front door cams and stuff like that, showing the water, the storm surge rising in layers. So if one of the first couple layers comes in here and it's being pushed by wind and several other factors, I'm not going to get into all the factors that contribute to storm surge, but if it's being pushed up the continental shelf and up the beach line, it has this upward trajectory, each layer of this water that's coming in, which means that it would have, if you break this angular direction down into its components, it would have an upward component and it would have a lateral component. Now, I showed you pictures of lateral force damage to the building, those soffits being pushed in and so on and so forth. And what I haven't really shown you yet is this evidence for this upward force here of the water. Now, my theory is this, and I will show you why. I'll give you some supporting evidence, if you will, for this theory. My theory is that as this water came up, the water pushed up the slab. As, let's say, the first bit of storm surge kind of comes in and it has this upward momentum, there's this property where it's pushing up underneath the slab. Not only that, the water actually does, the finished grade under the building does actually come to a close up at the front of the building, so it's trapped. It traps the water in there. So if you have a wave that sort of comes in here and that wave is pushed up, and then that wave wants to start, let's say that wave looks like this, and it wants to start moving down this way. But yet you've got another wave right behind it coming up and pushing this way. It's just like at the beach when the water starts drawing down the beach, and then the next wave comes up and there's this splashing and white foam and water goes everywhere. Well, this movement of water heading down the slope and this movement of water heading up the slope would collide and create a lot of outward force in all directions. And if you're trapping that underneath this, it's kind of basic hydrology, or hydraulics, I should say. And so you're creating this external pressure underneath the slabs. So there's a couple things that can lead to this upward force underneath these slabs. Now, why do I believe that this occurred? Well, those two collapsed units don't really give me enough information. I do know prior to going into them that there appeared to be lateral forces on the building from the storm surge, but how would I conclude that there was some sort of upward forces? Well, let's take a look at the units that were next to the ones that collapsed. So now we're going to look at Unit 3, and remember this is right next to Unit 2, which we looked at previously. So here's 2 on the picture, and here's 3. Now, looking at this, you can see the telltale soffit being crushed in there, the fascia there being pushed in, the loss of fascia there, the loss of the guardrail. So I'm not going to repeat all that stuff, but you can see the lateral forces that are involved. So as we go into this unit and we look down at the slab, okay, we are now positioned, this is Unit 3, and we're now positioned here looking right out the front door, okay? And if you look at the slab, you'll notice all of these cracks. We call this lateral cracking, okay? And lateral cracking is not completely unheard of in a topping slab, but the spacing is very rare. This is usually only induced by stress. So let me give you what I was seeing out here at the property. These precast slabs span like this. So I'm going to draw one of the precast slabs. They actually cracked at each of the slab joints, which is not a big concern for me because that's already a cold joint anyway where the slab is. So here's your planks running from left to right. And what happens is if the plank is bent, so the plank is sitting on a beam here, and it's sitting on a beam over here, and if the plank is bent upwards from this upward force that I'm theorizing happened, I'm hypothesizing happened, what you're going to end up with is, because concrete doesn't like to bend in that direction, you're going to end up with a bunch of cracks perpendicular to the plank span direction. And you're going to end up with those cracks along the top because concrete doesn't like to stretch in tension, so it's going to crack. And I believe that is what we're looking at when we're looking at these lateral cracks here. I believe you're looking at these slabs were pushed up, and then they settled back down. And I think what happened in the other units is that these slabs came up, and then they came down so violently as the water was kind of receding. You know, water comes in, pushes up, and then water recedes, and then the next wave comes in and comes down, and then the next wave, and it keeps getting taller. But I think very early on in the storm, there was an upward force that lifted these slabs, caused all of this immense lateral cracking. And then as that water recedes out, the slabs kind of collapse back down on themselves. And in units 2 and 5, the slabs could not handle that resettling, or they had taken too much damage when they got lifted, and when they came down, they just crashed and collapsed and broke all apart. This is another shot of that. Just I'm not going to draw on this one so that you guys can see the slab cracking maybe a little bit better on your phones or devices that you're looking at. And again, we are inside Unit 3 looking this direction, generally toward the front door, but I tried to angle the drone to be looking down at the slab. And the other reason why I know these cracks aren't pre-existing in the building is because they are unique to these units that saw the storm surge. No other units have these characteristic cracks in the slabs. So we're talking Unit 3 here. Now, if we move on to Unit 4, so here we got 2, 3, and 4. Before we even fly the drone in, I noticed that the ceiling here had been pushed upward. And you can see where it broke the plaster or the stucco or the paint, if you will, and it had pushed it up. It actually, you know, obviously, that's pretty obvious. It kind of blew out this little chunk here. But you can see that there's an upward force. There's a bend in the ceiling material right there. And I'll delete that so you can see it. But there's a crease in the ceiling where this has been pushed upward by some sort of vertical force. Yes, when wind hits the building, it does kind of create a force that can push in all directions. But again, these types of cracks and this type of upward movement on the ceiling of these first floor lanais was unique to the side of the building that saw the storm surge. And it's not visible on the other side of the building. All right, and so then as we get into this unit, all right, and now I've kind of turned the drone around and I'm facing in this direction, generally speaking. And again, you can see here's our control crack for where the precast plank is, and they either put in a really wide plank or we're missing one of the cracks, but that's fine. Or you know where the joints are for the precast. But you can see the next precast is there, and this precast plank actually goes all the way down. And then I know there's a precast plank at this corner because I've been around these buildings enough to know. And there should have been another precast plank line in here. But what's important to note is that's the span of the slabs. So the slabs would have bowed, if I'm correct and there was an upward force, those slabs would have bowed like this, right? They would have bowed in an upward direction, and then you would have ended up with all of this surface lateral cracking, which we can see here in the photo. So units 3 and units 4 were again sandwiched between 2 and 5, 5 being over here, up at the top right of your key. And so it kind of makes sense, right? I mean, if 2 took so much damage that it collapsed and 5 took so much damage that it collapsed, 3 and 4 must not be very healthy. I mean, and I think these slabs sort of tell the tale that they're not in great shape. All right, so now we're going to kind of compare this side of the building that saw the front edge or the leading face of the storm surge movement in, the lateral storm surge, and we're going to compare it to around the corner of the building, the same building around the corner from the storm surge. So this shot here is actually of the corner of the building. All right. And so this drawing onto the photo, this is the direction of the storm surge based on what we know of the storm. And this side of the building would have been protected from the storm surge. So we're going to start looking at pictures of this side of the building now. So if we look, this is our unit 5 that had that slab collapse inside the unit. And again, you can see that partial damage to the fascia there, and you can see the no damage to that fascia there. On this picture, some of the things you'll notice right away is you can actually see that this has guardrails on this side of the building. And guardrails. Not every unit does, but there's plenty of units that have them. None of the slabs on this side of the building collapsed inside the units. So basically, this is your separation wall here. Unit 5 being on this side, and units 6 and beyond go to the other direction. So everything 6 and beyond, which was protected from the wind. And again, here's 6, 7, 8, 9, 10, 11. So as you go through the building, you'll see that the damage is significantly less from 6 to 11. You can even see that these people still have their sliding glass doors, whereas in units 1 through 5, they didn't even have a piece of furniture sitting in their rooms anymore. I mean, there wasn't drywall left on most of the walls. Those things were stripped clean from the storm surge. Moving down the building a little bit, okay, so we see some guardrails that were lost and some sliders, okay, but you still got storm shutters up. You have no damage to these soffits down at the ground level. You've got no damage to the soffits above, fascias, soffits, whatever you want to call them. They're really faux beams on the below these slab edges, but you know, for the purposes of this video, I don't really care what I call them. But as long as I circle them and we all agree that we're talking about that thing. All the windows are still in place on the first floor. You can see the window frames here, and you can see the storm shutter in the windows here. And remember, on the other side of the building, the storm shutters were completely stripped off the building below the floodplain. And now we're looking, just to give you last orientation, we're looking roughly right here for this photo, I believe. Okay, so we're looking right about here for this storm, for this photo of the storm damage on that side of the building. All right, so getting back to the 6 points of a hurricane, the 6 features or qualities of a hurricane. The last one that we talked about was erosion, and erosion kind of comes with the territory with storm surge. But you can, like in the case of Hurricane Nicole, you can have very excessive erosion with less storm surge. You don't necessarily need the massive storm surge. What was interesting on Fort Myers Beach is that the storm surge sometimes brought excess sand in. I saw entire pools for condo associations filled to the brim with sand. I mean, from the bottom to the top, deep end to the shallow, the whole thing was just a giant tub of sand. Sand was covering the roads. I mean, they had to clear the roads of sand. I mean, metric tons of sand was just dropped all over the island. But then in some areas, the sand was completely eroded away. So it's really tough to say what storm surge is going to do as far as erosion is concerned. But if you look at some of the video that has come out recently on Hurricane Nicole on the east coast of Florida, you'll see that erosion damage, the erosion happened very fast and took down a lot of structures and did a lot of property damage. On Fort Myers Beach, we can even see images of the parking lots caving away 3 or 4 feet deep and showing drop-offs because of the erosion that went right past the building, right under the building, these buildings that were on pilings, and then eroded out the driveways, making for unsafe driving conditions. So I want to kind of close this video and ask a question, as a structural engineer, I'm not saying trying to make an argument from authority, I'm just showing based on my experience that I've designed a lot of buildings, and I've designed a lot of repairs for buildings. I've done a lot of consulting on buildings, and I can tell you storm surge has not gotten the attention that it deserves, especially here in Florida. Now, there are other parts in the world that see storm surge. You don't have to be hit by a hurricane to have storm surge. Outside of London, they have measures and walls that they can raise in order to prevent storm surge damage and things like that. So, I mean, there are technologies out there. There are a lot of engineers that understand storm surge. What I'm getting at is the way storm surge is going to affect a mid-rise structure or a high-rise structure on the coast. I don't know that there's a lot of thought in the codes, at least, that is put into how are you going to make this building to resist the lateral loads caused by the storms. One of the interesting things that we saw today in today's video is you saw that the sliding glass doors were completely blown out on the ground floor from the storm surge. Well, a lot of those sliders are probably older sliding glass doors. I mean, these new sliding glass doors we're building and manufacturing, and how thick the tracks are, I don't know that they're going to blow out just as easily. And what happens to that force that they are going to exert on the building as this water comes in? The other thing, that the code doesn't seem to really address is any of the uplift forces. I feel very, very strongly, this is not just this building and this video. I mean, I have seen, I think, 6 or 7 major condominiums on Fort Myers Beach, and at least 4 or 5 of them all exhibit an uplift evidence that there was uplift on the slabs, which caused either total collapse of some of the slabs or partial collapse or breakage of the slabs. And when you look at the cracks and you look at the geometry of the cracks, you can tell that the slab had been lifted and then put back into position. A hurricane is not, I'm telling you, is not going to lift. The hurricane force winds is not going to lift a balcony slab up a quarter of an inch or whatever and drop it back down. You're going to need something with mass, and storm surge certainly brings that mass. So I'm kind of at a loss. I don't have recommendations or ideas for how to deal with this, but I think it definitely warrants some thought and some new ways to look at buildings in order to design buildings. I think one of the things that needs to be thought of is not how to resist the storm surge, but one of the things that comes to my mind, especially when you look at Champlain Tower South, is how do we construct buildings and allow them to fail here or there, or collapse here or there without creating a domino effect. Thank God my clients on Fort Myers Beach did not have this cascading resulting effect of the slabs that they lost. Like I said, 4 or 5 of my clients have lost slabs and had slabs collapse, but thankfully they were all of the nature that they didn't affect the surrounding superstructure and bring the whole thing down like a house of cards. I can't say the same if these buildings were built out of post-tension or conventional reinforcement, but because most of these buildings that had these collapses were precast slabs, I think that's why they were able to get off without as much damage. Well, tell me what you think in the comments. You know, what ideas do you guys have for future-proofing buildings against storm surge? And I don't know, maybe you guys have the next great idea. Thanks for watching. If you guys like this content and want to consider helping out our channel, please check out our sponsor, 𝙈𝙞𝙡𝙀. 𝙈𝙀𝙀 is a website and app that utilizes interactive, hands-on learning to sharpen your mind and learn new STEM skills. These are lessons in science, technology, engineering, and math that will enhance your current understanding of how the world works, but also teach you new skills that you can actually use. Using the 𝙈𝙀𝙀 app is about growing your mind and learning useful things about how the physical world works. The content is broken down into courses like logic, scientific thinking, which are the 2 I'm currently working on, and other popular courses like computer science, applied algebra, or the one I'm excited to start, physics of the everyday. There are also learning paths you can explore, like real engineering, where you will explore the idea of throwing rockets into space instead of launching them with jet fuel, and you will apply what you've learned in physics and material science to see if this is an idea worth pursuing or not. In this video, for example, we looked at Hurricane Ian, and in previous videos we've looked at satellite imagery of that. In order to obtain satellite imagery of hurricanes, those satellites need to be launched into space from the ground. So this subject matter, like real engineering, is something that engineers and scientists are always going to be exploring. Again, one of my favorite aspects of 𝙈𝙀𝙀 is the fact that you can gift it to somebody else. It's a perfect gift for like a child or a grandchild to help their mind grow and expand. Viewers of this channel can sign up at brilliant.org/building integrity. And the first 200 of you that subscribe will get 20% off of your premium annual subscription. I want to thank 𝙈𝙀𝙀 for sponsoring this video, and I want to thank each and every one of you for your support. Thanks.